Okay. So in the periodic table, the elements are arranged. How elements are arranged in the periodic table? Are they arranged randomly? ऐसे उठा के रख दिया कहीं भी, or they are arranged on the basis of certain basis. The elements in the periodic table are arranged in order of their increasing atomic number from left to right in the periods, right? Let me write the exact thing. In the periods, right? So increasing atomic number. If you look at the periodic table, the first atom we have is hydrogen, atomic number 1. The very next atom is helium, atomic number 2. Then we have lithium, atomic number 3, beryllium, atomic number 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, and neon 10. So you see, this is the exact arrangement of how the atoms are arranged in the periodic table. So atoms in the periodic table are arranged in order of their increasing proton number. Similarly, we have sodium, which is 11, magnesium is 12, aluminum, this is the exact arrangement. And see, they are arranged in order of their increasing atomic number in the periods across left to right. And then 14 is silicon, phosphorus is 15, sulfur is 16, chlorine is 17, and argon is 18. So this is the evidence that atoms are not randomly arranged. They are arranged on this basis of their increasing atomic number from left to right in the periodic table. Now, periodic table, you all know that periodic table has, this is the basic structure of the periodic table, you know. So in which the elements are present, like these are the lines which separate the element, one group element from the other group elements. And we have the centered transition elements, and we have various other groups as well. 4, group 5, and group 6. So we have 3, 4, 5, 6, 7, and we have group 8, right? So top to bottom in the group, in the periodic table, the groups, they extend from top to bottom. This is group 1, group 2, this is group 3, 4, 5, group 6, 7, and group 8. We have total 8 groups in the periodic table. So what is a group in the periodic table, everyone? Groups are the vertical columns in the periodic. What are groups? The vertical columns. The vertical columns in the periodic table are called groups. The vertical columns in the periodic table are called groups. And groups extend top to bottom. Extends top to bottom. Right? So for example, this is the entire group 1. This is the entire group 1. And in group 1, it starts with sodium, guys. Starts with hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. This is all the members, all the atoms. This is a list of all the atoms present in group 1. So groups are the vertical column, extend from top to bottom, right? And all the atoms in the same group have the similar chemical properties. All atoms in the same group, for example, all group 1 elements show the similar chemical properties. All the atoms in group 1 in the same group shows similar chemical properties. So they show similar chemical properties. Why? Because all the members, all the atoms in group 1, for example, they all have one valence electron. Chemical properties depends on number of outer shell electrons, which are called valence electrons. So we can say all atoms in the same group show similar chemical properties due to, the reason is due to as they have the same number of valence electron. As they have the same number of valence electrons. Make sense, everyone? Chemical properties depends on number of valence electrons. So all the member in the same group, they have the same number of valence electrons. They show similar chemical properties. Similarly, all atoms present in group 2, they would have 2 valence electron. All element in group 3, they would have 3 valence electron. So they all react similarly. I'm talking about, let me just mark the attendance. It's extremely important. Okay. Similarly, all atom in group 5, they have 5 valence electrons. As long as you are moving within the same group, the chemical properties remains not the exact same, but similar. I said similar. So they show similar chemical properties because they have same number of outer shell electrons. So the chemical properties remain same. The physical properties changes. I mean the melting and boiling point and solubility, density, physical properties changes from top to bottom. Going top to bottom or bottom to top. So physical properties depends on atomic masses, since the relative atomic masses changes, so does the physical properties changes. So what is a group in the periodic table, guys? Group is the vertical column. Groups are the vertical column, extends from top to bottom. All the atoms in the same group show similar chemical properties due to the fact that they have the same number of valence electrons. They shows different physical properties because their relative atomic masses are different. How the atoms are arranged in the periodic table? Atoms are arranged in the periodic table based on their atomic number. I mean, elements in the periodic table are arranged in order of their increasing proton number. Correct? Yes. As the proton number increases, and they are present from left to right. And this is the evidence that hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and so on. Let's talk about periods in the periodic table, everyone. So we have periods. Periods are the horizontal rows in the periodic table. The horizontal rows in the periodic table are called period. Horizontal rows, and they also extend from left to right. Extends, so periods extend from left to right. And here is how the periods, so this is the first periods contain hydrogen and helium only. The second period, third period, similarly, the fourth period, fifth period, sixth, and there are total 7 periods in the periodic table. So periods extend from left to right. Right? This is how we can discuss the periods in the periodic table. They are the horizontal rows, extend from left to right. Both physical and chemical properties changes when you go across the period. So both physical and chemical properties changes across the period, because period में number of valence electron भी change हो रहे होते हैं, atomic mass भी change हो रहा होता है. ठीक है, physical properties change होती हैं क्योंकि atomic mass change होता है, chemical properties change होती हैं because number of valence electron also changes as you go across the period. Make sense, everyone? Please check this important information about the periodic table. First of all, how the atoms are arranged in the periodic table in order of their increasing atomic number from left to right. What are groups in the periodic table? They are the vertical columns, top to bottom. Atoms in the same group show similar chemical properties because they have the same number of valence electrons, or you can say outer shell electrons. And periods are the horizontal rows, extend from left to right. Both physical and chemical properties changes across the period. Make sense, everyone? Now, in our syllabus, there are 3 groups part of our syllabus which we need to discuss in detail. We have group 1 in our syllabus. We have group 7 in our syllabus and group 8. These are the three groups we need to know in detail. Group 1, let me show you exactly from the period. This yellow, which I labeled in yellow, this is one. They are called alkali metals. Alkali metals. Group 1 elements, the family name of the entire group 1 is alkali metals. Okay. Then group 7 is right here. The family name of group 7 is halogens. They're called halogens. And the family name of group 8 elements is called noble gases. Right? And this center part of the periodic table, the center of the periodic table, they are known as transition element, bit different than simple group. So the whole thing present here, they are called transition elements, also part of our syllabus. So group 1 alkali metals, group 7 halogens, group 8 noble gases, and transition elements is what is present right in the middle of the periodic table. Make sense, everyone? Now we will start with alkali metals. We'll learn the detail of every, what is required here and what examiner wants us to learn. Let's start with group 1, which are called alkali metals. Let's write all the alkali metals here in order. This starts with lithium, although hydrogen is there in group 1, but it is not a typical metal, it's a non-metal. It is in group 1 because it has the 1 valence electron. So that's why it is placed. Otherwise, it is not a typical alkali metal. It is not a metal even. So we have sodium, lithium, potassium, rubidium, cesium, and francium, all the group 1 elements. First, let's talk about the trends. In group 1, trends mean what changes as you move top to bottom. What happens to their chemical reactivity, to their density, melting and boiling point, and other features. So as you move top to bottom, the chemical reactivity increases. Chemical reactivity increases. I'm talking about top to bottom. Top to bottom. So which one is most reactive then? As you go top to bottom, the chemical reactivity increases. That means the one in the bottom must be most reactive because the chemical reactivity increases. So this is most reactive, right? Also, the density increases moving top to bottom. Density increases. So that is another trend. That means this is also most dense. Melting and boiling point decreases. Melting and boiling points decreases as you go top to bottom. So the trends in group 1, which are typical metals, the chemical reactivity increases, which means if you put francium and lithium at the same time in water, if you put lithium and francium, the exact same mass in the equal volume of water, it is the francium that would react violently, super fast reaction, because the reactivity, the trend is reactivity increases. So it is the francium that is most reactive, it is most dense, and it has the lowest melting point as well. The other properties includes, let's talk about some of the physical properties. Other properties, you can say, I'm talking about group 1. The typical group 1 properties are, they are soft metals. They are soft metals. Soft enough can be cut with knife. They're like burfi. I hope you know the burfi. Can be cut with knife. I ate a burfi few months back. There was an online ad, घर से घर तक, something like this. Wow. अगर आप इसे कोई बर्फी पसंद करता है तो must try that burfi. Super delicious. Although मैं मीठा पसंद नहीं करता, but वो बहुत मजे की थी. Okay, उसके बहुत ad भी आते हैं. So physical properties में सबसे पहला है, they are soft metals. Soft enough can be cut with knife. इतनी soft होती हैं कि you can literally cut them with knife. Other property is, they are less dense. They are what? Less dense. इतनी less dense होती हैं कि when you put them in water, they floats over water. So that is just for reference. They are less dense and they float over water, right? They are shiny, right? They are malleable. Since soft है तो ऊपर बता दिया, they are malleable, right? And they are good conductor because they have free electrons. As they are metals, they are good conductor. So please check this entire information about alkali metals. They are group 1 elements. The chemical and the trends, there are 3 trends part of our syllabus. The chemical reactivity increases as you go down. Density also increases. So the one in the bottom is the most reactive, most dense, but at the same time it has the lowest melting point, since the melting point decreases as you go top to bottom. So lithium has the highest melting point in group 1 because the melting point decreases. At the same time, it is least reactive. It has the lowest density. I'm talking about lithium. Other typical properties are they are soft metals. Soft enough, can be cut with knife. They're very less dense. They floats over water. They are shiny. They are malleable, and they are good conductor of current as well. Make sense, everyone? They all, the other important feature is group 1 elements, they loses 1 electron. They all loses 1 electron and form cation with a +1 charge for all of them, with 1 plus charge. No matter if it is, if it is lithium, sodium, potassium, they all have 1 valence electron. So they all lose 1 electron to form a cation with a +1 charge. Make sense, everyone? Yes. Done. Guys, ho gaya? Please confirm. Inshallah, I'm planning to, solve more past paper with you guys. Just a quick revision of the entire course. And of course, then we will do plenty of past papers. It is again the past paper which will help us to understand the core concept that how the examiner will test your understanding in this. So you will see we will do nothing more or short than what examiner according to the Cambridge syllabus. So for periodic table, I think you all have now a good understanding that how the atoms are arranged, what are groups, how the periodic table is designed. It is designed in groups and periods, the vertical column and the horizontal rows. What remains the same in groups? The number of valence electrons. Chemical properties remain the same. And what remains same in periods? The total number of occupied shells. So we can say that the total occupied shells remains the same as long as you're in the same period. For example, let's say we have sodium. The next atom is magnesium. Next atom is aluminum. They are the atoms present in the same period. Let's write the configuration of sodium. 281. How many occupied shells? 3. 2 in the first shell, 8, and then 1. So total 3 occupied shells. For magnesium, it is 2, 8, and 2. Again, the total number of occupied shells remains 3. For aluminum, it is 2, 8, 3. So in the period, the total number of occupied shells remains the same. So since they have 3 total, this particle, sodium, has 3 occupied shells. So we can say that it is in third period. Occupied shells tells you the period number. And it has 1 valence electron, so it is in group 1. So last shell electron tells you the group number, and the total occupied shells tells you the period number. So this is very important for us to understand. Then we have group 1 and group 7. I hope aapne likh liya. The total occupied shells tells you the period, and the outer shell electron tells you the group number. So now periods are the horizontal rows, and we have 3 groups in our syllabus, group 1, 7, and 8. 1 are alkali metals. There is no need to learn all the metals. You will be given with the periodic table. So we just need to know the exact concept. The trends: chemical reactivity increases, melting point increases, density decreases. And they are soft metals. They are less dense, shiny, and malleable. Let's talk about halogens, and then we will complete our today's class. So group 7, they are called halogens. अच्छा, group 1 में you must know that they all have metallic bonding. इनमें क्या होती है? सब में metallic bonding होती है क्योंकि metals है ना. So when they react within themselves, they have metallic bonds, strong metallic bonds. So halogens are bete. Halogens, they starts with fluorine, chlorine, bromine, and iodine. Look, I'd never write F or Cl. They are diatomic. So they exist as diatomic. They all are non-metals, exist as diatomic, which means a molecule contains 2 atoms. A molecule contains 2 atoms are called diatomic. Now, both fluorine and chlorine, they are like gas at room temperature. This is also gas. This is liquid at room temperature. And this is solid. So you can clearly see that the melting and boiling point increases top to bottom this time, unlike group 1 in which the melting point decreases. यहाँ पे reverse है. उसमें reactivity increase होती है, यहाँ पे decrease होगी. वहां melting point decrease हो रहा है, यहाँ increase हो रहा है. Fluorine is pale yellow gas. It is a pale yellow gas. This is greenish yellow gas. This is brown liquid, and this is gray black solid. Right? These are their state at RTP, physical state, and this is their colors appearance at RTP. Make sense? Now again, the trends here. Number 1, the chemical reactivity decreases. Chemical reactivity decreases top to bottom. The chemical reactivity decreases top to bottom. Number 2, a melting point increases. Melting and boiling point increases top to bottom. Right? And the third trend, which is density, it remains same. Density increases top to bottom. Top to bottom. So this is very easy, I think. ग्रुप 1 के बिल्कुल ऑपोजिट हैं दोनों ट्रेंड. यहाँ पे केमिकल रिएक्टिविटी डिक्रीज हो रही है. इसका मतलब फ्लोरीन इज मोस्ट रिएक्टिव. टॉप है, सबसे ज्यादा रिएक्टिव, लेस एंड द लीस्ट. केमिकल रिएक्टिविटी डिक्रीजेस. Melting point increases. Fluorine has the lowest melting point, higher, and the highest melting point. And then density increases as you go down in group 7. Please check this important thing, everyone. So they all have a 7 valence electron. All have 7 valence electron. They all gain 1 electron and form ion with a -1 charge. For example, fluorine have 1 minus, chlorine have Cl -1, Br -1, and I -1. Makes sense, everyone? But I mentioned the reactivity decrease. They react with group 1 elements. For example, sodium is in group 1, it loses 1 electron. Cl is in group 7, it gains. So they react with group 1 element and form ionic compound. Like, for example, sodium chloride is the perfect and the most common ionic compound that we have. Right? Important thing in group 7 are the displacement reaction. The only thing that we need to know here, the displacement reactions. And the idea of displacement reaction is, the principle is most reactive halogen or more reactive halogen, more reactive halogen displaces the less reactive, and less reactive cannot. For example, है क्या ये बात जो मैंने की? Let's say you have sodium chloride. आपके पास जो halogen है वो chlorine, the halogen is chlorine, और ये aqueous है. Aqueous solution की बात हो रही है. Let's imagine you react it with fluorine. Now fluorine is F2. जब कोई अकेला लिखा हुआ है तो वो diatomic है, जब bonded form में तो वो जो भी formula बनेगा. Let's react with fluorine. Now you know that the order is fluorine ऊपर है, chlorine नीचे है, फिर bromine और फिर iodine, right? अकेले लिख लें, naturally room temperature पे diatomic. Top to bottom reactivity decrease हो रही है, इसका मतलब fluorine is most reactive. Now इन दोनों में fluorine ज्यादा reactive है, chlorine definitely fluorine. तो fluorine more reactive है, it will displace the chlorine. So what you will get NaF and Cl2 will be displaced. जब वो displace होगा तो अकेला हो जाएगा तो वो diatomic होगा, Cl2 बनेगा. बैलेंस करने के लिए यहाँ 2 लिख लेंगे, यहाँ 2 लिखेंगे तो सोडियम 2 हो जाएंगे, तो यहाँ पे भी 2 लिखेंगे, फ्लोरीन पहले से बैलेंस. That means fluorine being more reactive can displace the less reactive. For example, let's do another. Let's react the same NaCl with Br2 this time. अब मुझे बताएं कि do you think Br can displace the chlorine based on its position? Cl is more reactive clearly than Br because it is above. So when you reacted them with less reactive, you would say there is no reaction as Cl is more reactive, or you can say Br is less reactive than Cl. So this is quite important. So group 7 में बेटा हमने halogens पढ़ा है. They are diatomic. उनके colors, उनकी appearances, their features, and the much important displacement reaction. So today we started with periodic table, and inshallah we will complete it by tomorrow. And then, as I said, we will do collective past paper worksheet from 3 chapters, 1, 2, and 3 combined in next 2 or 3 classes, and then we'll start with acid, bases, and salts in the further classes. So periodic table is extremely easy. Atoms arranged on the basis of their increasing atomic number, classified as groups and periods. I'm talking about the periodic table. Groups are the vertical column, periods are the horizontal rows. We studied group 1 and group 7 in detail. We'll do group 8 and transition atoms tomorrow along with the past paper questions. So if you have any question, please ask. Thank you. You have no question. See you tomorrow, inshallah, same time. Allah Hafiz.